Welcome back to AI Mind Studio. In this video, we're answering one of the most important questions in artificial intelligence. How do computers actually learn? Not memorize, not store data, but truly learn from mistakes. We'll understand two key ideas today: loss and gradient descent, explained simply, with intuition, not heavy math. What is gradient descent? Gradient descent is the optimization algorithm that AI uses to reduce error and improve predictions. Whenever a model makes a mistake, gradient descent helps answer one simple question: which way should we move to reduce this error? You can imagine it like walking on a hilly landscape. You start at a high point, meaning high error, and your goal is to reach the lowest point where error is minimum. Gradient descent helps the model take small steps downhill, one step at a time. Intuition behind gradient descent. At every step, the model checks: should I increase this parameter or decrease it? Based on that direction, it slightly adjusts itself to make a better prediction next time. So learning doesn't happen in one big jump, it happens gradually through many small improvements. Step by step learning. Here's how learning actually happens. Step by step. First, the model makes a prediction using its current parameters. Then it calculates the loss, which tells it how wrong that prediction was. Next, it computes the gradient, which tells it the direction and size of change needed. Then it updates the parameters slightly in that direction. And finally, this process repeats again and again. Each repetition makes the model a little smarter. Why this works? This works because the model is constantly correcting itself. With every iteration, it becomes better at spotting patterns in the data. It doesn't magically understand things, it learns through repeated feedback and adjustment. That's the core idea behind machine learning. Learning rate, step size. The learning rate controls how big each step is during gradient descent. If the learning rate is too large, the model overshoots the minimum and becomes unstable. If it's too small, learning becomes painfully slow. But when it's just right, the model steadily moves toward better performance. Think of it like walking downhill, not jumping and not crawling. Training is repetition. Training an AI model means repeating this process many times. Each full pass through the dataset is called an epoch. Models often train for thousands or even millions of iterations. Over time, the loss decreases, predictions improve, and the model starts learning meaningful patterns from the data. How this applies to neural networks? In neural networks, gradient descent powers the entire learning process through something called backpropagation. The loss is calculated at the output layer. Then gradients are sent backward through the network. Weights and biases are updated layer by layer. This is how deep learning models learn complex patterns like images, language, and speech. Big picture. So let's step back and look at the big picture. Loss measures how wrong the model is. Gradient descent shows how to improve. And learning is simply the process of reducing errors step by step. There is no magic, just mathematics, repetition, and feedback. Overfitting vs underfitting. Now let's talk about two common problems in learning. Overfitting happens when the model memorizes the training data. It performs well on training data but poorly on new data. Underfitting happens when the model is too simple and fails to capture patterns. It performs poorly on both training and test data. The goal is an ideal fit, low error on both training and testing data. What's next? In the next videos, we'll start connecting learning with mathematics. We'll explore linear algebra basics and calculus for machine learning, including derivatives and gradients, all explained intuitively. Thank you for learning with AI Mind Studio. Subscribe, stay curious, and I'll see you in the next video.